Alright, we're going to continue on. This is the Grandmaster video for Chapter 6, Sections 1 and 2. We're going to talk about dependence versus independence and what types of relations they are. So we've actually already covered this, so this should be a good review from the previous video. So we have relation. These are all written as equations. We have no graphs, and we're not asked to do any sort of graphing. We just want to determine which variable is independent, which is dependent, and is it linear or nonlinear. Okay, so previously in the last video I mentioned that the variable that is isolated, the one that's by itself, that typically is the dependent variable. So we say y is dependent. Doesn't always have to be, but typically is. So therefore x is independent. So that's the one that we're typically free to choose. Independent. Okay. The question is this relation linear or nonlinear? So is it a straight line or is it not straight? Well, we can do that by looking at the exponents of variables in each term. So we have this one, that's an invisible 1, and that's an invisible 1. We don't need to look at this because there's no variables there. So the degree of each term, that means the total number, the total value of the sum of all the exponents in each term. Well, this is just 1, and that's just 1. So it's linear. Next, well, y is isolated once again, so that is dependent. Typically when you have x and y is always dependent anyway. Very rarely is it the other way around. X is independent. Okay. All right. Let's have a look. Well, here's a term containing variables. Well, x, the exponent there is a 2. This is an invisible exponent of 1. Okay. Well, the degree of this term is 2. Okay. So right away, I don't even care what this one is. I know right away that this is nonlinear. There we go. Okay, the next one, well, we're choosing different letters, but it doesn't matter what letter you choose, X or Y, N and M, P, Q, doesn't really matter. So in this case, N is isolated, so I would argue that N is dependent because it's by itself. Therefore, M is the one we're free to pick numbers and evaluate, so it's independent. All right, is it linear or nonlinear? Okay. Now, don't fall into the trap and think, oh, there's a 2 there. Okay, remember, 45, that is not a variable. Okay, it's just a number. It's 45. It's a constant. It does not change. Therefore, 45 squared. Albeit it's a big number, but it's still just a constant. It does not change. So we're only looking at the exponents hanging off of a variable. That's an invisible 1. That's an invisible 1. So in each term, the grand total of exponents is just 1. So again, this is linear. All right, last one, v. We're using v and t, so this is an equation. Maybe it means velocity, and maybe t is time. Often we choose specific letters to model what it is we're trying to describe. So if you're talking about height, we might use h. T for time, things like that. All right, is it linear or nonlinear? Okay, well, here's a term with a variable here, and the only exponents we see, grand total, in each term is 1. So the degree of each term is 1. So this is linear. So we have 3 linear relations and 1 nonlinear relation. All right, here's a nice review from before. We talked about discrete relations versus continuous relations. So here we have a graph with a bunch of dots plotted. Horizontally we have frog leaps. The unit is n, or the variable is n. And then we have distance, m, I guess that's meters. And notice how these dots are not connected. And they shouldn't be, okay, because if horizontally this represents how many times a frog jumps, it wouldn't make sense to plot a dot at the 3.5. Okay, frogs don't jump 3.5 times. Okay, they either jump once, twice, 3 times, 4 times. So they have to be whole numbers. So this is definitely a discrete relation, okay? Because the points are not connected, and they shouldn't be. Okay, if they were connected, the graph would not make sense. How do you jump half a time or a third of a time? All right, there we go. All right, the next graph, however, this is distance versus time. Okay, so maybe this is the distance traveled. Well, this is in meters, so it's probably not a car. So I would say this is perhaps a person. Okay, so they're moving, and then they stop moving, and then they're moving backwards, and then they stop moving. But we don't care about that so much as we just want to know, is it discrete or continuous? Well, we have line segments that are all connected. And remember, a line segment, or any line, is actually just a collection of infinitely many points just squished really, really close together. So all points are included. There are none missing. That's continuous. You may say, there are no points. Yes, there are. There are infinitely many. They're all connected. Points are connected. There you go. All right, here's our first critical thinking problem. There are two common methods for calculating interest, simple and compound. Suppose simple interest yields 2% of the invested amount per annum or per year, but compound interest, that yields 2% of how much you have in your account per year. Okay, so they're slightly different. Suppose you invest $1,000 and you graph the interest earned versus time. Which type of interest forms a linear relation? So in other words, if you were to graph it, interest earned versus time, which would be a straight line? Explain why, and state which quantity is independent and which is dependent. Assume no money is withdrawn. Okay. So I'm actually going to answer this last part first, because I'd say that's pretty easy. We have two quantities. We have the interest earned and time. Well, which one depends on the other? Well, it wouldn't make sense to say time depends on interest earned. We would say the interest earned depends on how much time has gone by. So time is independent. So time I'll represent with T. So T is independent. Right? Which means the interest earned, which I'll represent with a capital I, that depends on time, so that is the dependent variable. So I is dependent. So there we go. Okay. Now the question doesn't say specifically to show a graph. It just says if you invested and if you were to graph it, which would be a straight line, which would be linear. Well, we can actually determine this without graphing. You can do some graphing if you want, but we actually don't need to. Let's first talk about simple interest. Okay, well, we know that year zero, so in other words, time equals 0 because time is in years. How much money, how much interest would we have earned? Okay, well, we wouldn't have earned anything. We would have our $1,000, but that's what we originally put in. So the amount of interest is actually 0. Okay, now at t equals 1, okay, remember, time is in years. So 1 year has gone by. So that's when we do our first interest calculation. So we are told that we get 2% of the original amount. Okay. So what is 2% of 1,000? Now this is a simple percentage that you should be able to do in your head with no calculator. Okay. Because we know that 1% of 1,000, well, we can just shift the decimal 2 places. That would be $10. Therefore, 2% would just be $20. So the amount of interest earned would be 20. So that's not how much money you have in your account. Okay, you would have $1,020, but we're just talking about how much interest that you've earned. So a year later, so this is the end of year 2, so time equals 2, we calculate interest again. Okay. Well, simple interest is only calculated based on the original amount, and we invested $1,000. Okay, so the original amount, that does not change. So we know that every year we earn $20. Okay, so we had $20 before, we add another 20, So now the interest earned is 40. Let's do one more year. Time equals 3. One more year later, we just added another 2% of our original amount, which was $20. So our total interest earned is 60. You can also use this formula. You may have seen this before. This is a formula for simple interest. Okay, I equals principal, which is the original amount you invested, so that would be the $1,000, times the rate, so that would be my percentage, so you'd write that as a decimal, and times the time. Okay, so that's actually another formula that you can use. All right, well, let's see if these values form a linear relation. And we'll use the same technique that we did with the ordered pairs that we saw in a previous video. So from time equals 0 to 1, okay, that's an increase of plus 1. Okay, and so was this. Okay, 1 year was going by. Okay, and here, notice how the amount of interest we had always increased by $20. Okay, so for every year, our interest earned increases by the same amount. Okay, this is linear. So if I were to create a graph and label it beautifully and use a color printer or however glamorous you want to make it, a straight line would be shown. So you may think, well, I'm not even going to bother checking compound interest, and I guess you'd be right, but it doesn't hurt to learn a little bit more about compound interest, so let's talk about it. Compound interest is different in that the interest is calculated not on the original amount, that doesn't change, but it is calculated based on how much money you have in your account at the end of that year. And that is always changing, it's always growing. So compound interest, you actually get more money. So if you were to choose between one or the other, usually you'd want to choose compound. Okay, so at time equals 0, so after 0 years, okay, that's when we first did the investment, so obviously we're not going to earn any interest. Okay, so same as before. And because there's more going on with compound interest, I'm actually going to make a note here of how much money we actually have in the account, because that's what we use for compound interest. We didn't need that for simple interest because the original amount was $1,000 and that never changes. So we have $1,000. Okay, I'll just put a title here. I don't know. Account balance, just to help us keep track. Okay, so 1 year later, so 1 year has gone by. How much interest would we earn? Well, we had $1,000 in the account, so that's all we can use. So 2% of that is $20. We had 0, so 0 plus 20 is 20. So after the first year, we've only earned $20 worth of interest. Again, it's the same as simple interest. Okay? But the amount in the account has now changed. Okay? I have the $1,000. Again, we're not withdrawing anything, but $20 in interest has been earned. So now my account balance is $1,020. Okay? This is the balance we use to calculate, to help calculate the interest for the next year. Okay, so that's where our numbers are going to start to look different. Okay, so this is time equals 2. So after 2 years, okay, well, in this year between 1 and 2, we earn 2% of this number. Okay, you can do that in your head because 1% of 1,020, just move the decimal over, will be $10.20. So to double that, to get 2%, we would have $20.40. Okay, so from 0 to 1, we earn $20. From 1 to 2, we earn $20.40. So the total interest earned after 2 years is $40.40. Okay, so comparing that with time equals 2 for simple interest, we actually now have a little bit more money. So now in the account balance is, we still have the 1,000, but now we have $40.40. worth of interest added on. And now this amount gets used to calculate the interest for the next year. So it's definitely a bit more complicated. There is a formula. You're not expected to know it, and maybe at the end I'll just give it to you. But there is a formula that you can use to calculate each year. But the formula itself doesn't really explain anything, so that's why I'm doing it this way. Okay, so from year 2 to year 3, okay, that's 1 year, how much interest do we earn? Well, again, it's always 2% of the account balance. So 2% of $1,040.40, okay, that is $20.80.8. I guess if you want to say it like that. So we have to add that to the previous interest of $40.40. So that gives us 61.208. So this would be approximately $61.21. So we can verify. So all these times, those are an increase of 1. Okay, but I think it's obvious these are not a consistent increase of 20. This is plus 20, but that is plus $20.40. Okay, and then that one was an increase of 20.808. So no graph is necessary. Okay, I can see that this is not the same. So this compound interest is non-linear. All right, now I did say I would give you a formula for compound interest. Not going to derive exactly where it comes from. You don't need to memorize this or anything like that, but I'll just explain it quickly here. It actually comes from the formula for simple interest, but when you repeat it year after year and you keep adding the account balances over the years, do a bit of algebra, you get this. So the interest earned, if it's compound, it's the original amount you invest, so that's the principal, times 1 plus the rate. Okay, so the rate in our case was 2%, so this would be 0.02, and you raise that to the power of t, where t is in how many years. And of course, well, this actually gives you your account balance, but if you just want the interest earned, you just then subtract off the principal. So that gives you what you earned in interest. So that's compound interest, and this is simple interest. Okay, so you're welcome to use your calculator and experiment, play with numbers. So let's actually verify that this is correct using time equals 3. Okay, let's see if we actually get an interest of $61.208. So I'm going to work out these brackets first. So of course 1 plus 0.02 is just 1.02. So that's in my calculator. Now I need to raise that to the power of 3 before I multiply by my principal. So I'm going to raise 1.02 to the power of 3 equals, and you get 1.06 blah blah blah. So now I'm going to multiply that by p. So our principal was 1,000, so times 1,000. Okay, so that number now, the $1,061, that is how much money I have in my account. But if I just want how much interest I've earned, well, I just take away what I originally invested, which is $1,000. And lo and behold, you get 61.208, which is exactly what we had here.